So we're going to talk tonight about chapter 5. So this is a continuation of the classes, with object-oriented programming. We're going to do part 2 of that tonight. And there we go. Okay. I'll do some announcements. We'll do lecture. You guys will do studio. Same old, same old. So announcements, and Colin mentioned this already in the class announcements channel. We are moving the schedule around just a little bit because I'm going to be unavailable on the 28th. So class 9 is now moved to Monday the 25th, and then the catch-up class will come after that on Thursday the 28th when I'm out. And then because of that, we're going to move the deadline for graded assignment 2 to the following class, Monday the 2nd of October. So you get a little bit more time on that. Yay.
Congratulations.
Oh, yes, thank you. The intro video for graded assignment 2 will be up soon. I will certainly let you guys know once I have it done, sometime in the next, probably this weekend. Okay, so without further ado, let's talk about classes part 2. So we're going to talk about the final keyword, what that means in Java and how you typically use it. We'll talk about the difference between, I'm sorry, give me a second. The difference between instance fields and methods and static fields and methods. And then we'll talk about constants, which all, kind of brings that all together. And then we're going to take a break, and when we'll come back, we will talk about special methods. We're going to talk about overriding the toString method that's built in to every Java class. I'm going to talk a little bit about the StringBuilder class. This is not something that is, I think, strictly referenced necessarily in your chapter. But when you're looping through through like a collection or an array or something, and you want to build a string with, element by element, the StringBuilder class is really what comes in handy there. So I'm going to demonstrate that for you. And then we'll talk about overriding the toEquals method that comes built into every Java class. And then I'm going to talk just a little bit about, the IntelliJ generator, the pros and cons of using that to create all of these methods and things. All right, so let's talk about the final keyword. So the idea here is that you can prevent a value from being overwritten by using final. And so strings and primitives, as you would expect, cannot ever be changed again. Once you give them a value, they're good. But collections, arrays, methods, those kinds of things are where, because they're objects, you actually can't overwrite them entirely, but that doesn't mean you can't change the things that are inside them. But it prevents you from completely replacing like an array list with another array list or something like that. And sometimes that's useful. So because you aren't intending to change the value, it only makes sense that your final fields would have getters, but not setters. You can declare a final field at the beginning of your class without actually initializing it, as long as you set the value in the constructor, because that runs when the object is created from that class. And so it's going to just, set it that way. And that can come in handy. I'll give you a good example of that tonight. So there's an example here, that you have a book ID, and we're going to assign that value in the constructor. So I've just, declared it, but I haven't initialized it. And then I might have a getter for that, get book ID. And if I go and I, want to access the value of it, I can just use that getter from the main class, right? So that final keyword is what prevents that value from ever changing, and that's why there's no setter. Okay, now let's talk about instance versus static, because as you know from before we started talking about object-oriented classes in Java, when you guys were first learning this, the first couple of classes, and you were like, for instance, when you did the area class and the circle class, you were calling values that were stored at the class level. There were no objects of the class, right? So when you have an instance field, it's where every object has unique values, but when you have static, that's where a single value is stored for the entire class. So you use the static keyword to declare that, to make that possible. And then you access them on the class name, not on the object name. Even if you do have objects of that class, if it's a class level field or method, you want to access it based on the class name. And if you're not sure when a method should be static or an instance method, pretty much the rule is if it relies on instance field values where every object has unique values, then you need it to be an instance method. You don't want to make it a static method. I'll do some examples for you of these as well in just a second. But just to kind of look at this diagram, this is the same book class that we talked about last time. But the idea here is that maybe you want to start assigning ID numbers to these books, right? So you can have a book ID that is a instance field stored on every single one of the books, and they're all unique, right? But maybe you have a value for a number that you want to track because you want to make sure that the number that's on the end of each of those IDs is unique as well. And so you might store that at the class level as a static field so that you can only change it every time you create a new object, but it always stays at the class level and doesn't actually get attached itself to each object. I'll do a little bit of coding on that for you and you'll kind of see how that all connects. So before I do that, we are going to do, by the way, a lot of live coding tonight. I have very few slides and lots of code. But let's talk about constants, because this is where final and static come together. A true constant has the same value no matter what, right? But there's no constant keyword in Java. So instead, we use a combination of static and final. And the static keyword is what ensures that it's stored at the class level, as it should be, because it's the same for everything. And the final keyword makes sure it can't be changed. So when you use them together, they're stored at the class level and they can't be changed. You always reference them because they're static using the class name and not an object of the class. So I've got an example here where I've created, this all formats field. And static will let me store it at the class level because I want it to be, it's just data that I want to make available to all objects, but I can store it at the class level and only have to store it once because it's not going to change. And because it's not going to change, I'm going to add the final keyword to make sure it can't be overwritten. And so I could call that, all formats. And then if I want to reference it from the main class, I certainly can, but I'm going to call it from the book class. I'm not going to call it from some particular book object that I've created, as an instance of the class. So that's just an important distinction there. Anytime you reference a static method or a constant like this, you want to make sure to call it on the class. Okay, so let's do some coding and then I will take some questions. Okay, we're going to go back here to our book and library example that we were working on last time. So you remember there's a title, an author, the number of pages. We've got this Boolean available that starts off as true when you create a book because you haven't checked it out yet. And we have our constructors, one that you specify the pages and one that you don't. And then down here, we have our getters and setters, and we have these instance methods that concatenate the title and author together nicely for us, check the book out, check the book back in. Remember this? Okay. So we're going to work on this. And what we want to do is add this ID. And so we need to have, a class level field that's going to hold the next available number. So that anytime a book is created, it's going to use that number to create the ID. And in this case, I'm going to make a more complex ID than just using the number itself. Although, typically it's very, very common, most common to just use the number. So I can just, make this private and also make it static because I want it to be held at the class level. And I'll just make it an int and I'll call it next ID number. And I'll just initialize it to 1 because the very first time I want to create a book, we want to start with 1 for the first book. So then I need something that's actually going to store the book ID at the instance level for each individual book. I'm just going to say this is private, it's final because I don't want to change it once it's been established. It's a string, and I'm just going to say book ID. It's a string because I'm going to use multiple characters, not just the number. And you'll notice IntelliJ is got this squiggly red line under here and it's saying it may not have been initialized. That's normal because I haven't initialized it yet, right? It's saying you can't make it final and also, not initialize it. Well, I have a plan, no worries. We are actually going to initialize it in the constructor here. So this is perfectly valid as long as you do it in the constructor after the fact. So what I want to do here is make sure that the title, author, and number of pages have already been set because I want to make use of those values. So on the next line of this block of code that gets run, because remember, constructors are just methods that get run when the object is created. So I can, put anything in here that I want. So I'm going to set this book ID as, and really I could just say book ID if I wanted to, because like this, because I don't have a competing parameter for this. So book ID would be fine too. And I'm going to call a method down below. So I'm going to comment this out for a second because I want to be able to concatenate a number of values, and it'll be a lot less messy to do that in an instance method than to try to do it right here in the constructor. So I'm going to write a separate method for this. And if I come down here to here, past here we go. Yeah, we want to define an instance method to generate this book ID. So here's where we can kind of put all of this together. We want it to be private because we want it to be called only from the constructor. No one else is going to have access to this. It returns a string, so I'll give it a return value of string. And then I'll just call it generate book ID. And we want to use this format. So it's going to return a string that's in the format author initials dash first three letters of the title of the book dash the next available number. And that's where our static method, our class level, field comes in. Our next book ID number. What did I call it? Next ID number. There we go. So we're gonna make use of that here. All letters should be capitalized, and we want to make sure not to forget that once we've executed this code and assigned this, that we also need to increment that that static value so that a new number will be available in the class for the next book that is created. So we'll do all of that here all at once. The other option would be to actually do that part. You could do it in the constructor, like right after we do this, right after this assignment. Either way, but I'll just do it down here instead. Okay, so let's go ahead and write this. So I'm gonna say I'm gonna build this string here. I'm gonna say sorry, give me a second. Oh, right. I forgot to mention. Okay, before I do that, over here in the utils file, I've created a new file here, a utils class. This has a method called getInitials that actually goes through the full name and splits it and gets the character from the first index of each of those words and then puts them together and returns that. Now this uses StringBuilder. We'll come back to this because I want to use this as an example to explain what that does. But all you need to know for now is it returns the initials. Okay, so I'm going to say string ID equals. I'm going to call, that's a static method. So I'm going to say utils dot getInitials. And then I'm just going to give it the author from this particular object. So this is an instance level field, right? And then I'll concatenate that with a dash. And then I'm just going to go straight to the title instance field and say I want to get a substring from 0 to 3, just those first 3 letters, to uppercase. And then I can concatenate another dash. Okay, and then this is where we get the next ID number. And all of that together will make our ID, and then, oh, I forgot my plus sign here. All right, IntelliJ is real good about pointing those kinds of things out for you. And then I'll just make sure to increment. I'll say, next ID number, and just use the plus there to increment it to the next number. And now it'll be ready at the class level for the next book, now that we've used this number up. And then I'll say return ID to return this that I built. So we can call this now generate book ID right here in the constructor and say, we want to set the book ID to generate book ID. And it'll go and it'll piece all those things together because, and again, it's important to put this after these three because we depend on the title and the author in order to form this up. So those need to be set first, and then we can call this and we'll have access to those values because they're now being stored up here in these fields. Okay, so that will work. We do actually want to add getters here. Let's see. I'm going to just use the generator and say I want to add getters for both of these, but I'm going to, let's see, move this down there, because that actually goes with that to do, right? And essentially, this one's fine. It just returns that. And, I chose, like if we wanted to access the book ID, this is public and it's fine. And it'll get it once it's been set here. And that's fine. We just don't want to set her, right? Because it's final. This one, really, I'd like to customize this just to show you that it can be done. I mean, sometimes you want to use just the regular thing, but what if I actually wanted to customize this for some other reason? I could say, something like, wait, actually get rid of that space. There we go. The next available number for a book ID will be, and then I can, just return that, right? I've got an issue and I don't know what it is. Required int provided string. That's correct. Okay, so that's the other thing about it. Because next ID number is an integer and I used the generator, it automatically assumes that the return value is meant to be an integer, right? But I decided I wanted to return a string instead. So all I have to do is just modify that and now we're good. So you can do that in certain cases if that's how you want to be able to, that's how you're going to use that getter is to get information in a certain way. You can certainly customize it. Okay, so over in our main file here, let's go ahead and print the first available ID number just so we can see that come out, and that's going to use that getter that I just modified. So I'm just going to say print, and now let's go to the book, because remember that's a class level. It's a static field. So I call that on book directly, even if I haven't created any book objects. So we can do that, and then I can run it. So let's go ahead and see how that comes out. All right, so we see the next available number for a book ID will be 1. So that's exactly what I just created. And then we've got, some additional things here left over from last time, but we're going to build on this. So we've instantiated these book objects from last time, but let's go ahead and print their ID numbers and also prevent the next available ID number, in between each of them. So you can see how that works with that value being changed every single time at the class level. So here I will just, say print and say something like, book 1 has an ID of, and then just concatenate that and say book 1. So this is instance level. I'm calling it on the object get book ID because it's going to have a unique ID. And then I can do the same thing for the other ones. Let's see. I got to get used to my IntelliJ stuff. It's different than VS Code. And every time I switch back, I lose my muscle memory. Okay, so this one we can go to book 2 and book 3, and I'll just do that. Okay. And then the other thing was I wanted to, duplicate this one, right? So let's just do that as well. We'll print that after each one to show that static field is being updated at the class level each time. Okay. All right, so the next available number is 1, and we have book ID has an ID of CS-CON-1. The next available number for book ID will be 2. And accordingly, when we added this book 2, it was given, IA-NEM-2. and so on and so forth, right? So we've created 3 books, and now it says the next available number for a book ID will be 4. And if we were to create more books, it would just keep going like that, because we're updating that class level variable, that static field, every single time we assign a very specific book ID to each of the objects that are created from this class. Okay, so that's a pretty good, starter on, how these static and final keywords are used. There's one more thing we can do over in library. Let me, it's a little bigger. We had created this array list of books last time, right? Where we can, instantiate a library and then add to this list of books every time we add to the collection. But we want to make sure that this entire list can't be accidentally overwritten. So I'm going to actually add the final keyword here. I'm also going to take the private keyword off, because I would like for books to be directly available on the package level and not only available in this class. So I can say, oops, got my caps lock on. There we go. So I'm taking private off and I'm adding final. So now we can't just take the entire collection and accidentally overwrite it with a new list. But it will now be available, and we can prove that by coming over here now and, I'm going to go ahead and do this. It says, test the toString method of the book class. Every class has a built-in toString method, right? That automatically is there. So let's say, we could print the book, and so I would just, say, let's print book 1, right? And then I can do the same thing down here and test the toString method of the library that's built in. And you may remember this from last time, what happens when I do this. Yeah, so for the book, we get class04.book at 180BC464. So remember, the built-in methods with these objects, they end up just returning that location in memory. So this is where overriding the toString methods for a class can be really helpful, because we can do whatever we want with that toString method and incorporate whatever data we want from the class. We can format it however we want. We're going to talk about that after the break. Who has questions right now about final and static and constants? No questions. Okay, no problem. Okay, so I know it's early to be taking a break in the lecture, because it kind of feels like we just got started, but we have a lot to do afterwards. So I want to go ahead and do this now. So we'll take this break and then come back and talk about these special methods. Okay, welcome back. All right, we are going to talk about these special methods. The first one is how to override the toString method for a class. So toString, as I mentioned before, is automatically provided for in a Java class. And we already proved that when you print it, you end up just, pointing to that location in memory. It doesn't give you any useful information at all about, what that class represents. So you can call that on an object, but you don't have to. If you go to just print it, it's going to automatically call toString. And so that's why sometimes, you go to print it and it calls it, and then that's what you get. So you can customize it. This is much better. And then it'll print exactly what you want, and you can format it however you want. There is an annotation. So this is a term that might be new to you. Annotation, these usually begins with an @ symbol. And it's something you place above a field or a method. And this one, override, it's not always required, but I recommend you just add it all the time, and then you don't have to worry about when it's required and when it's not required. So I always add it when I override, to be explicit. So we're going to do that. We're going to override a toString. I'm trying to decide if I want to talk about, let's go do one, and then we'll come back and talk about the StringBuilder class that I mentioned before, and then we'll do one for that as well. Okay, so let's take a look in here at book, I think. This is where, we're going to do something really simple for book. And something that I'm going to talk about in a little bit. I got to get in the right one. Here we go. Something we'll talk about in a little bit is how you can use the generator to do this. So we could, do that and say, I want to generate a toString method. And I'll say, which of the information do I want? Really, I'm going to end up doing my own thing, but let's just choose num pages and book ID for now, because actually I could choose all of these. How's that? Everything except for available. And it's just going to give you something like this. So that's, it's a place to start, right? So like if I have this now and I go and I run this again, then at least instead of seeing that funny location in memory, you get something like this. But this isn't really, it's still not very pretty. It's got information in it, and that's great, but it's not pretty. So let's do something really customized, right? Let's do something completely different. I'm going to actually say that I want to return, and I'm going to force a new line at the beginning, so it'll push it down in the console a little bit. And then I'm going to say, I'm just going to use my get title and author instance method that we wrote before to go ahead and say, book title by author name. And then I'll concatenate another new line to go to the next line and say, give me the number of pages, and add the text pages. And then I'm going to go to another line and say ID colon, and then I'll concatenate on that book ID. Okay. So let's run this again and see what it looks like now. Yeah, there we go. Contact by Carl Sagan, 430 pages, ID CS -CON-1. So, all I did was override that method so that anytime, you like all I did was say print book 1, right? Here it is. Yeah. System.out.println book 1. So it automatically calls the toString method when you do that. And if you've overridden it, then you get something really nice instead of that, crazy location in memory, or, even the thing that I, did override, but I just used the generator for it. It was still not, super nice. This is going to be much more usable, because we can actually make good use of this when we go to override the toString method for the entire library. And maybe we want to print a whole list of all the books in the library. We can do that. And it'll look nice like this if we incorporate this. So that's one way to do that. That's a pretty simple example of how to do this. When we go to do the library, we're going to use that StringBuilder method. So let's talk about that. The StringBuilder class is a way to build a string whenever you need to loop over some sort of collection and just build that string bit by bit. It doesn't quite work the way that it does in JavaScript, where you can just keep like concatenating. So the first thing you want to do is declare a new object in the StringBuilder class. And you'll just, make sure that the import statement ends up at the top as you do that. And then you'll loop over the array or the collection, and you use this append method of the StringBuilder class to add it to that object. And then after you're done looping and you've added and added and added, you can just convert that to a string if you need to. If you actually are concatenating that final object with some other things, it automatically will convert it to a string for you. So it's going to depend on the circumstance. I'll show you an example of each. So in this example here, I've got, an array of strings, a simple array. And I know this is a really silly example, and you'd be like, why would you bother to go through the trouble of looping through this to create launch code? But I only have so much room in my slide, guys. So I used a really simple example. So we've got 2 words in our array, but imagine if we had more. You would want to loop through them, right? So I can say, create a StringBuilder object, give it that type, and say, create a new StringBuilder object. And we'll just, call that constructor and create it. And I'm calling it LC. So now we're going to loop through the words word at a time. And every time we do, we'll append whichever word we're on as part of, that array of words. And append is what, and IntelliJ will even warn you if you try to use concatenation with the plus sign, it'll say, don't you mean to use append? Because it knows. So once you're done with that, then the last thing to do here is to convert it back to a string if you need to, so that it can actually just be used as a string. So I created a new variable, string launch code, and said LC .toString to call it. And now I have a string launch code that has the words launch and code concatenated together. Okay, so this is how this works. So let's go see how an example of it. I'll show you the example we looked at before in the utils class. This is where I was getting the initials. So I was passing in the full name of the author and saying, I want to create a StringBuilder object called initials. So I create that new StringBuilder, and then I say, okay, let's split out those names so that I have an array to work with. So I create an array of strings called names. I take full name, I split it by spaces, and that gives me each name separately, right? Then I loop through those names and take the character at index 0 of each one and append it to my initials object. That's a StringBuilder object. And then I return that, but I need to return it to string. And I also, my specifications in the class, in the book class said, make it uppercase as well. So I went ahead and did that. So this will always return just those initials after going through. So if a person has 3 names, it'll take all 3 initials. If they have 2 names, it'll take the 2, etc. Now, obviously, this would not work perfectly in every possible situation out there, but it works for what we're doing. So with that in mind, that's an example of using StringBuilder. Let's go over and actually code it ourselves in the library class by writing a custom toString method here that will print a list of all the books with kind of a title or a header line and all that kind of stuff. We're going to make this particular toString is going to be a lot fancier than the one that we did for the books, but it's going to take advantage of what we wrote for the books. Okay. So again, I want to, and I'm not going to use the generator for this one. I'm just going to completely code it. So I'm going to start with that override annotation. And then I'm going to say public, return value is a string, toString. And then I'm going to tab over this to make sure that that import statement gets added at the top. And I'll say all book info equals new StringBuilder. And the purpose of this is going to be just to build the list of books because we have multiple books up here in our array list, right? So I'll create that, and then I'll say for book of books, just like that. And so for every single book object that's stored in this books array list up here, I want to look at them one at a time. And I'm going to take my StringBuilder object, all book info, and append book.toString. So remember, we've already written that nice toString method for it that gives us on 3 lines, the title and author and number of pages. So I'll do that, but I don't just want that because otherwise all the books are going to run together. So I'm also going to append a line to separate them out. And I'm just going to do like a new line and then like a bunch of just hyphens. This is just the console, right? So you can only be so fancy like that. And that will separate each one as it goes through and give us a nice clean look that's easy to read as we get our list of books together. So now all of that is stored in a single string builder object. So I can say, here's what I want to return. I want to return, welcome to our library, and then have a couple of new lines. And then I want to add, okay, something, I can say kind of whatever I want. Let's see, view our full collection, which if you had a real library, this would be ridiculous, right? There'd be way too many things to look at all at once, but I'm rolling with it. Okay. And then I'll just do another line that's just to, have some sort of separation after this prints out. And then, so after that header is done, this is where I can just say, now go get all book info. Now, I said before that string builder objects have to be converted back to strings, right? But I also said that if you concatenate it with something else, it automatically does it for you. So I don't need to explicitly call toString here because I'm concatenating it together with all these other strings. It's going to be created, it's going to be converted into a string automatically. Okay, so let's, you remember last time we printed the library right here, we were getting this location, right? So let's run it again now that we've customized toString and see what we get. I'm gonna pull this up so you can see the whole thing. Here we go. Welcome to our library. View our full collection, and then each book's information is added using its toString method one at a time until we have the whole list, and then it returns, this entire thing together. And that's the result of our custom toString method for the library. So this is super useful, very commonly done when you need something to be formatted just so. Okay, so that's pretty much it for strings. Who has questions about the string and string builder stuff? No questions. Okay, no problem. All right, so let's talk about the second special method that we want to override. And this one is a lot more in depth, guys. So buckle up. This is the way to check to see if an object is equal to another object. So equals is automatically included with every class, just like toString is. But they've got it set to check identity by comparing the locations, which really doesn't make it any better than using the double equals, right? Because all it does is say, yeah, that's pointing to the same thing. Maybe it's just an alias or something, right? So that's when it would return true. If you want to be able to actually see if something is equal based on the content of the object, like certain values in the fields, then you're going to have to customize it. So again, this annotation override is not always required, but recommended. So I'm always going to use it, and I recommend you do the same. So that's the big picture. Now let's talk about all of the pieces of this process of customizing, because there's a number of different things that you want to do. First of all, you want to type the argument. You want to, and that really should say parameter. You should have a parameter of the equals method, and it's common to use something like to be compared, because you're just saying pass something in, and I'm going to see if it's equal to the thing I'm looking at. So this is the object to be compared, and you want to give it the generic object type because you don't yet know whether it's actually of that class or not. And it's just going to be part of the verification process, is we're going to see if it's actually that. But before we even do that, we're going to do a few other things. So there's a number of different ways that we can check to see if something is equal or unequal. And in the meantime, it's better to just have it be a generic object type. But then when you are ready to cast it, once you're sure, you can use parentheses like this to cast it. You go ahead and give it the type, you have a new variable name and say, I want it to be of, of class library, and then you use that to be compared value. So this is where you store it in a new variable as an object of that class. So that is, but in between these two things, we have some other things we need to do first. So first, you want to make sure that you've got these extra checks with some early returns, just in case you can tell off the bat that something is not actually, that there's no way that they're the same thing. First of all, the reference. If they do have the same identity, then return true, because clearly they're not even two different objects. One is just pointing to the other one. Is it null? Is there not even actually anything to that argument that can be compared? Then just return false. What if they're different classes? If you can tell already they're different classes, then just return false. And so you can go through the process with it being an object type generically, because that's, in the inheritance structure, that's, a parent or grandparent or whatever. You can just do that. So we'll go through this process of checking reference, checking null, checking for class, before we, and once we get through all of that, that's when we can say, okay, now we can cast it to this class once we're sure that it's not the same thing in memory, it's not null, and it is of the same class. Once we know those things, we'll cast it, and now we have something that we can use that's of this class, and we can go from there and have logic that will actually say, here's how the basis on which we want to compare them. Maybe it's just based on the ID numbers, maybe it's based on the name, or a title, or whatever. And we might have multiple things that we want to do, but we can write that logic however we want and say, this is how we want to compare the data that's inside these objects to decide whether we consider them to be the same or not. And that's what we're going to define equality as, not just location and memory, like the default. Okay, so I'll mention this before we go in and do some of this. I mentioned before, the IntelliJ generator can help you do a lot of things. We've covered, constructors, we've covered getters and setters, and then, toString and equals. You can generate these equals as well. A lot of times I prefer to write them from scratch, just because I want to go through that sequence very intentionally. But more importantly, whatever you decide to do, if you do use the generator, this is what you want to keep in mind. Just don't ever assume that the automatically generated method is what you need, because sometimes you're going to make changes. And I demonstrated that already when I decided to change that next ID, get next ID, to be a string instead of an int, and actually return a sentence, right? But that's especially true when it comes to toString and equals. You are probably going to want to modify it and not necessarily use what they give you, depending on what it is you need. When we get into working with databases, and some of the stuff that we're going to do in Spring, then probably the generated one is going to be sufficient. But for now, because we're working in the console, we're definitely going to want to define things very specifically. Okay, so let's go do that. Let's look at book first. We're going to come up here and, oh, I'm sorry. Am I going to do book? I think I'm lying. Hold on. Yeah, I'm lying. We're going to do library. I'm not going to do one for book. Books are pretty straightforward. What I'm really interested in is demonstrating, like, how would you tell if one library was the same as the other one, based on more than just their location. So we're going to do something that's a little bit more thorough, that has a little bit more complexity to it, because this is going to take a little while to go through, and so I'll just do this one. Okay. So I'm saying write a custom equals method to compare the contents of the books, books being our array list that's up here, full of multiple book objects, right? So again, always use override. And then we're going to write this method that is public. It returns a Boolean true or false. It's either equal or it's not equal. And we'll call it equals, and again, object to be compared. We want to start with whatever it is that's to be compared, but keep it really generic at first and just make it an object. And then in here, we're going to do a reference check. We're going to do a null check. We're going to do a class check. And then if we verify that they are the same class, then we can cast to the class. And then we can do a couple things with something like this. To me, the size of the list would be an immediate way to tell whether they're the same or not. So we might as well check that first. So let's compare the size of the lists. And then we also can actually, at this point, write the complete custom comparison of the contents of the list, where we are checking certain information. And in this case, I'm going to define that as just checking the title and author, and seeing if those are the same, because maybe that's what defines same or different for me. Okay, so we will do all of these things one at a time. So let's start with the reference check. All we really need to do is say if, and then remember we refer to an object. If we're referring to that object of the class within the class, we use this, right? So I'm just going to say if this equals to be compared. So this is just an identity check, so I can just use the double equals. Are they the same thing in memory? If so, we just have an alias, return true. On the other hand, what if one of them is null, right? So, or if the thing that's to be compared is null. So I can say if to be compared equals null, return false. They're clearly not the same object. Now let's check for class. We'll say if, and there's this built-in thing, just get class. You can just call to get the class. And then you can say if it's not equal to the thing to be compared, dot get class, then you can return false, because clearly we're not even talking about two objects of the same class. But once you've confirmed those, now it's time to do something a little bit more specific. So we'll cast it first so that we're actually working with a library object. I'm just going to call it other library. And use the parentheses for the casting. And then say to be compared. So now we're taking to be compared, we're casting it to the library, and we're storing it in a new variable. From now on, we'll be working with that new variable because we need it to definitely be of the library class. Okay, so first I said we were going to compare the size of lists. That's pretty straightforward. So we'll say if books.size is not equal to other library.books.size, then we're going to return false, because they clearly can't be the same if they have different numbers of books. Okay, and then if it passes that, this is where we need to look at them book by book and check the contents, right? So I'm gonna loop through and say for every book in books, and I'll start with the books that actually belong to this object, and say let's go get the index. So I'm going to go to the other library, and I'm going to call this instance method that I wrote down here called find book. So basically, it's going to take the title and author, because that's the information I'm interested in, and it's going to go and find it. And if it finds it in the other library, then we can say that it exists, and if it has an index, and the index is either going to be a positive number or 0, or it's going to be -1. So we'll do this, find book and pass in book.getTitle and book.getAuthor. Okay. For what we're using those getters for that book object to get those values. And we'll pass them into, find a book down here, so it can go through and get the index in that library. So if that comes back, and it comes back as something other than -1, we're good. But if the index is -1, then we know that we can return false. And so that's an early return. So as soon as we come across that situation where we have a book that we can't find in the other library, then we know they're not equal and we can return false. But if it gets completely done looping and it never hit that logic, then we know we can return true. So we finally have a return true at the very, very end. Okay. So let's do a little bit of work over in main to kind of explore how this works. We're going to create a second library. We're going to have some second books and some second libraries. I'm going to, for the sake of time, let's see. Yeah. I'm just going to paste this in because I really don't want to type all that out. Okay. So it's exactly the same information as our first books, Contact by Carl Sagan, et cetera, right? So the goal here is we're going to prove that it can return true because we have, the exact books, but they're not books 1, 2, and 3. They're books 4, 5, and 6. They have different identities or different, locations in memory. They're completely new books, but, and they're going to have different IDs, right? Because they're going to have IDs that end in 4 and 5 and 6 instead of 1, 2, and 3 because of that static next ID number we created. But we're only interested in the authors and titles. So this is how our custom equals method is going to benefit us. All right, so let's create the second library and add the books to it. So I'm going to say library 2, and just say we're creating a new library. And I want to do library 2 dot add book and give it book 4. And then I can do the same thing with books 5 and 6 here. And then we can go ahead and test whether these are actually the same. So I already have this printed out. Are the two libraries identical? So if we just use the strict equality operator here, we can say, let's check library equals library 2. Are they the same library in memory? But here we're going to actually use our new custom equals method that we decided, we want to check on a basis other than just their location in memory. We want to actually check and see if it contains all the same books with the same titles and authors. So we'll use library.equals and then pass this in. And then when we do that, library 2 becomes that to be compared argument, right? So we're comparing library against library 2. So let's run this and see what happens. Okay, are the two libraries identical? False. Are the two libraries equal? True. Because they have the same books, same number of books, the same books, titles, and authors, even if though the books are actually themselves different objects from the first 3 books. Okay, let me see if there is, I think that was the last thing that we were meant to do here. So yeah, who has questions about equals? Oops. Anybody have any questions about that? No. Yeah, yes. Devin.
Yeah, if does the thing you're overriding, the new descriptor of it needs to be named exactly the same, right? You can't override an equals with like equal library, like as name in the method instead.
Yeah, if you're overriding, it has to have the exact same signature. Yeah.
Got it. Thank you.
Yep. Or same name. Yeah. Tammy?
Hello. I'm curious about whenever you're doing your new equals method, the casting, whenever you're casting it to the class, I'm just curious about like why you might be trying to find out if 2 objects of different classes were equal to each other. Can you speak to that a little bit?
Sure. Like, let's say you're coming in here and you're doing this and you're checking, library equals, and you pass in something thinking that it was an object of that class, and it turns out it's an object of something else. Because of some other code you've got somewhere else that's just doing this, right? This will prevent that from failure because it's going to check to make sure that it is in fact an object of that class before it then starts to check everything else after that.
Okay, so it's maybe whenever things are a bit bigger than right now, we can see everything that we have.
Right.
Okay, thank you.
Yeah, maybe you're getting some stuff from one API and you're getting something else from other API, and they're supposed to be the same kind of object, but they're not necessarily.
Okay, that sounds very realistic.
Yeah. So you just have all that logic in place to prevent that from being a problem.
All right, thank you.
Exactly. Any other questions? This lecture went much faster than I thought it was going to. Okay. Well, you guys get extra time in studio tonight. Look at that. All right. So next, coming up down the pike, we've got class 5 on Monday. That is the chapter 6 prep work on unit testing. Then we're going to do inheritance, the class after that, chapter 7, and then interfaces and polymorphism the Monday after that, chapter 8. Lots of good stuff coming. Okay, so for tonight's studio, you're going to pick up where you left off in the last studio, where you had come up with these 2 classes for your restaurant menu and menu item. And you had taken care of establishing what fields you wanted, and then what that constructor might look like, and maybe the getters and setters. But now you want to continue filling it out, designing some methods and things like that, so you can actually have some functionality. Using that main method in the main class to code a program that can run, so you can create some menu items, add them to the menu, and then print that out. Perhaps you have a customized toString in the middle of all of that. And then I think there's a bonus mission. Let me check here. If a user tries to add an item that's already on the menu, print a message that warns them about the duplicate. So if you wanted to see that is already there, you're probably going to need a custom equals method, right? To be able to see if it's the same item based on certain criteria. Maybe it's just the name of the item. Maybe you're checking, some other thing about it, depending on what fields you've set up and data you have about that menu item. So that would be a really interesting thing to do if you have time. You guys also, I know that graded assignment 1 is due today, and a lot of you are scheduling demos with your TAs, so you'll have time for that as well during studio. So I am going to go ahead and send you guys off, and I will get up the videos for the lecture and the studio review later tonight.